quadratic function y is equal to 2x squared plus 2ax plus a will have the minimum value m when x is equal to 2. Solve for the addition of two constants a and m. At first, let's think about the two cases in our quadratic function, but they're all defined by one thing which we call it as our leading coefficient. And our leading coefficient will going to be the coefficient in front of the highest degree power term. And if you think about in our function in this case, the highest power degree term will going to be the x squared, where the x is our variable. So its coefficient, which in this case will going to be the leading coefficient, will going to be 2. But then we usually notate it as a. The reason is because it is a coefficient, which means it depends on time, it varies or it changes. So that's why we call it a. So for our first case in our quadratic function, we're going to be the case where the a, our leading coefficient, is greater than 0. The a is greater than 0, which means when the a value is positive value, the graph of our quadratic function will go upward, or we usually call it as opens upward. When the quadratic function's graph opens upward, for example, it will look something like this, that never intersects at some specific point. But then it will gonna contain a particular point right over here, which is one of the most important thing that we need to know in the function or the quadratic function. It will going to be a minimum point of its quadratic function. But for a minimum point, we also call it as the lowest point of our graph. And the minimum point will going to be defined when the a value, our leading coefficient, is positive value. So if you think about the another case, the second case of our quadratic function form, will going to be the case where the a, our leading coefficient, is less than 0. Which means when the a value is negative, the graph of our quadratic function will go downward, or we can say opens downward. When the quadratic function's graph opens downward, for example, it will look something like this, that keeps going toward downward, never intersects at a specific point, but then it will going to contain a one particular point. And this is another important thing that we need to know in the quadratic function, which we call it as the maximum point or the highest point on our graph. And the maximum point will going to be defined when the a value is less than 0. And we usually hear the term vertex when it comes to solving for the quadratic function problems. If you think about the definition of the vertex, it is essentially the same thing with adding the number possibility of the minimum point and the maximum point. So if we add those two number possibility, we're going to end up being or getting our vertex of our quadratic function. And they will all going to be defined by our leading coefficient, which we notated as a in this case. In the question they said in our function y is equal to 2x squared plus 2ax plus a, we're going to have the minimum value m when x is equal to 2. That means it is referring that our m value will going to be the y coordinate of our function's vertex. So at first, let's write our function down here. Our function was y is equal to 2x squared plus 2ax plus a. So from here, we can know one thing, that from our vertex of our quadratic functions, our x value will going to be positive 2, and for our y value, they said it will going to be the m. And m is one of the choices or the cases where we need to solve for it. So we can write m as the y coordinate. So from here we can note one more thing, that for our leading coefficient will going to be 2. So in this case, this function will open upward. And when the quadratic function's graph opens upward, we can also prove it through here. This quadratic function will only contain a minimum point, which we also call it as lowest point. So we can see that in this case, the vertex of our quadratic function will going to be the minimum point. From our function, we can know one thing, that our function is formed by the standard form. The standard form and the standard form's basic format will going to be y is equal to ax squared plus bx plus c. And then let's think about other values. So we know that y will obviously going to be the output of our function. And for our a, the a is the leading coefficient, which defines our type of our function as we did in the upside. For our x, the x will going to be the input of our function, which will going to be the variable. Now let's think about what will going to be the c. The c will going to be the y-intercept. And for it will going to turn into a constant. And if you think about the word constant, it is same thing with just a number without any variable, such as 2 or 3. Now let's think about what it is to be the y-intercept in the function. So for a y-intercept, if we convert this into a coordinate, it will turn into 0, y, which means when the x value is equal to 0, our y value exists. But the reason why we don't write this specific y value is because it is also a variable which varies every time. So y-intercept means when the x value should always be equal to 0 and the y value always exists. So this is what the standard form is. But if you think about our format in our quadratic function that is most optimized when it comes to solving for a vertex, we're going to be the vertex form. Now let's think about the basic format of our vertex function, which is vertex form, which is optimized when it comes to solving for the vertex of our function. So our vertex form will going to be y is equal to a times x minus p, and then square plus q. And this is also a different types of our standard form, and this is going to be our vertex form. Now let's think about its variables. And for y and x are obvious things, that y should always be the output of a specific point or the function. And now let's think about what is a. A should always be same. Also, the a is our leading coefficient, which defines our two types of our functions. And now let's think about what is p. So for a p here, it will going to be the x coordinate of a vertex. So we can just say x coordinate of the vertex. Now let's think about what is the q value in our vertex form. The q value will going to be the y coordinate of the vertex form, or the vertex of a specific point, unlike the P. So this is what the vertex usual form is. And if you think about the way how to convert this into a vertex form, like how we convert the standard form or the binomial form into a vertex form, is same thing with completing the square form, which we call it as a perfect square form. So perfect square form is essentially going to same with the vertex form, whereas optimized when it comes to solving for the vertex of a function. So we need to convert our standard form into a vertex form, and if you write our function down again, which will going to be y is equal to 2x squared plus 2ax plus a. But we need to find a way instead of converting this into a specific function. The reason is because for here it contains too many variables inside it, which will going to make our calculation even more harder. But we can use our property that we used from here. So at first, let's write our functions vertex x comma y, which will going to be the vertex's coordinate. So this will going to be when x is equal to 2, our y value will turn into m. But then we can input our values to our original function. The reason is because we know that p will going to be the x value, which will going to be the input of our function. But then 2 here becomes the input of our standard form. So that means we can put this into a p terms. And for a will going to be the leading coefficient, but then we know our a value, which will going to be 2. So all you have to do is we need to input value of a as 2 to our vertex form. But then we know one more point. We know that for the y vertex, y coordinate will going to be the m. So in order to solve for this question, we need to keep inputting some values. So if you input it, it will look like this. Y, which will going to be the output, is equal to a. Instead of a, we can write 2. Then times x minus, instead of p, we can write our x coordinate, which will turn into 2. We still have square. But then we still have our q value, which will going to be the y vertex, and we can convert as m. So if you think about our vertex, our variables again, m will going to be the y coordinate of our vertex. 2 will going to be the x of our x coordinate of our vertex. And then if you think about 2 in this case, the 2 will going to be the leading coefficient, so which will going to be a. Y, so with y will always going to be the output of specific point or the function. Now all you have to do is, at first we see x minus 2 squared. All you have to do is we need to convert this into a standard form. The reason is because we know that our original function 2x squared, y is equal to 2x squared plus 2ax plus a is a standard form. And if we convert this into a standard form again, we'll be able to compare its terms. So let's write our function down again. Y is equal to 2 times x minus 2 squared plus m. According to the order of operation, we always calculate x minus 2 first. And because there is a square term, it will turn like 2 times x squared minus 4x plus 4, and we still have plus m. But we need to know one more thing here. From the m value, which will going to be the y value, should always be a constant. And we know the constant will going to be the term that refers the coefficient but with no variable. So at first, for the x squared minus 4x plus 4, but then we can use our distribute property and distribute 2 in order to remove this parenthesis. If you do that, we're gonna get simply an output. We're going to get 2x squared minus 8x plus 8 plus m. But we know that this is essentially going to be same with our original function. Y is equal to 2x squared plus 2ax plus a. So we can write that down. The only reason why we could compare this is because there is information that they're all same. If they are not same, we won't be able to solve for this. So let's actually compare this. So first of all, 2x squared is equal to 2x squared, which means all of them are same. So here is 2x squared, and here is also a 2x squared. And now there is another one. Negative ax should also be equal to 2a. So, secondly, if you write more neat way, the second information that we're given is negative 8x is the same thing with positive 2ax. The reason is because they both contain a first degree power variable, which will going to be just x in this case. So our 31 will going to be 8 plus m is equal to a. These three terms will going to be the given informations that is crucial when it comes to solving for this question. So first of all, we don't have to calculate 2x squared because they're always same. But then we need to calculate negative 8x is equal to 2ax. Here we can divide 2x to the both sides in order to isolate the a term, which is essentially going to be the thing that we want to find. And then this will going to be x, 2 cancels out. X, 2, and then negative 4 will left. And negative 4 is equal to a. So negative 4 is equal to a. We're going to be first thing that we found from our equation. And the only reason why we could do this is because there is a thing or information that they're equal. So for the second one, 8 plus m is equal to a. So a plus m is equal to a. But then we know that a value is equal to negative 4. So we can input a value as negative 4. But then it will turn like negative 4 is equal to m plus 8. From here, all you have to do is we need to subtract 8 to the both sides in order to isolate our m term. We're going to get m is equal to negative 12. So this will going to be the second one that we want to find. But then this is not our answer. Our answer, so the thing that we want to find is the constants a, m addition. So we can write a plus m is same thing with a value is negative 4 plus m value is negative 12. Negative plus negative will turn into negative. This will going to give us negative 16. So our negative 16 will going to be our answer for this question, and we can write it down here. So our answer for this question will going to be negative 16.